In this video, we're going to start talking about breathing. Before we get into the actual mechanics of breathing, we have to talk a little bit about pressures in and around the lungs. The first pressure that we need to talk about is atmospheric pressure. Atmospheric pressure is just the pressure that the molecules of the air are putting all on the outside of your body. At sea level, this pressure is going to be about 760 millimeters of mercury. As you go higher in altitude, that pressure is going to become lower. So those molecules of air are going to be putting less pressure around your body. So when we're talking about pressures in relation to breathing, we need to remember that all of the pressures that we talk about are going to be in relation to that atmospheric pressure. So if we say that a pressure is zero, that there is no pressure, the pressure is zero, we're actually talking about a pressure of 760 millimeters of mercury. So zero respiratory pressure is actually 760 millimeters of mercury. When we're talking about a negative respiratory pressure, that means that it's going to be less than 760 millimeters of mercury. So if you look at this diagram here, you can see that this pressure right here is less than 760, so that is going to be a negative pressure. A positive pressure is going to be anything greater than 760. So if you see a pressure listed as something as 761, 762, that means that it's going to be considered a positive pressure. So as we're talking about different pressures in the thoracic cavity, you need to remember that 760 is actually zero. Anything above that is positive, anything below that is negative. So the first pressure we're going to talk about inside the lungs or inside the body is going to be the pressure inside the lungs. So this pressure in here, inside the alveoli, inside the lung cavity itself, that's going to be our intrapulmonary pressure, or you can also consider it your intraalveolar pressure. So again, the pressure inside the lungs, inside the alveoli within the lungs. This pressure is going to rise and fall throughout the breathing cycle, but it always is going to eventually equalize with atmospheric pressure. So it's going to go a little bit above atmospheric pressure and then go back and then go down a little bit below, but it always is going to come back to atmospheric pressure. Intrapleural pressure, this is going to be the pressure that we find in the pleural cavity. The pleural cavity is that space in between the two pleural membranes, so between the visceral pleura that's lying on the outside of the lungs and the parietal pleura that's lying right on the inside of that thoracic cavity wall, the pleural space is right in between. That has its own pressure. That pressure is always going to be negative. It's always going to be a little bit below atmospheric pressure. It will rise and fall a little bit throughout the breathing cycle, but it will never equalize with atmospheric pressure. The factors that cause this intrapleural pressure, this negative intrapleural pressure, there are two factors that are working together that are trying to shrink or make the lungs collapse down to really, really small. And those two pressures are the lungs' natural tendency to recoil. So lungs are made up of elastic tissue. So this tissue, just like a balloon, if it doesn't have any air in it, it's going to shrink down as small as possible. The second thing that is going to try and make the lungs shrink down is the surface tension of the fluid that's in the alveoli. Just like if you were to spill some water on a table, it's going to want to try and ball up because of that surface tension. The liquid inside of the alveoli in the lungs wants to do that as well. So we have these two forces inside the lung that are trying to make that lung shrink down as small as possible. Then we have one force outside the lung that is trying to pull the lungs out and make them bigger. And this is the elasticity of the chest wall that's pulling the thorax outward. So kind of the fight or the battle between these two pressures, or these three pressures, the two pulling the lungs in and the one pulling the lungs out, those two opposing forces are going to cause this negative intrapleural pressure. If that intrapleural pressure ever does equalize with the atmosphere, if it ever does become zero and equal with the atmosphere, like what would happen with a chest wound if you were to get stabbed in the chest, and air rushed into this intrapleural cavity, and equalized with the outside air, then this lung would shrink down. So those two inward pressures would then win, and that lung would shrink down. So they would need to insert a chest tube in here, suck the air out, inflate the lung, and then patch up this hole in order for you to be able to breathe again. That would be called a pneumothorax, and that's what happens when air gets inside this chest cavity and the chest cavity pressure equals atmospheric pressure. If you get a wound and it fills up with not only air but also some blood, then you're going to have a hemopneumothorax as well. Same treatment's going to be the same. They're going to put a chest tube in, suck out the blood, suck out the air, inflate the lung, and then patch that up. So that's going to be it for this video. In the next video, we're going to talk about the actual mechanics of breathing.